So this is how it works. Okay, so okay, here okay, so what does it mean to compute the inverse? If we have a square matrix, a square matrix has the same number of rows as columns, then inverse A is such that A times A inverse is the same as A inverse times A equals identity. The identity matrix has ones on the diagonal and zeros above and below the diagonal. So how do we do this with Gauss Jordan elimination? How to compute with Gauss Jordan elimination? Well, what you need to do is you need to write. So remember, we wrote A, B for AX equals B. Right? So instead of writing A, X equals B, we'll write A and I being the identity matrix. And then we'll do some Gauss Jordan elimination to reduce A to I. And we know how to do that because what Gauss Jordan does is basically creates the identity matrix from A. So it turns out if you can reduce A to a identity matrix, then on the right side, you'll automatically recover A inverse. Okay, it's kind of, I guess it's, hopefully it's obvious why it's true. Okay, so so how do you use this? Well, if AX equals B, then a solution to X is A inverse B, right? So there's use of computing the inverse, which is if you know the inverse, you just take that, multiply it with B, and then you have your X. So it's very useful. Let's see how to do this for the same example. So here's an example. I'll stick to the same one so we can check against other things we did. Example. Solve AX equals B using matrix inverse obtained from Gauss Jordan. Okay, so the equations are A is 2, 1, 1. It's the same matrix I wrote earlier. It's not something different. 2, 3, 1. So 2, 2 minus 1. Okay, and then that's A. And then B is 7 minus 2, 3. So our goal is to compute A inverse. That's the first step. And the second step is to compute X using A inverse times B. Okay, so Gauss Jordan expects us to write A and identity. So A is 2, 1, 2, 1 minus 3, 2, 1, 1, 1, then 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so we do the same thing, which is identify the pivot, reduce the pivot to 1, So this will do it. 1, 0.5, 0.5, 0.500, and everything else remains the same. The next step is to eliminate these two guys, 1 and 2, by using the pivot in row 1, column 1. For that, we need to do my new row 2 is going to be my old row 2 minus, always take the pivot first, 1, and then divide and multiply with, in this case, 1 times row 1, and then row 3 equals row 3 minus, the pivot goes down, this 2 goes up, row 1. Okay, so we've gone through this process of using Gauss Jordan earlier. So what I'll do is I will not do the steps here. I would rather have you do them, just using the same Gauss Jordan elimination I talked about earlier. So it'll just be a repetition here. So I just write down the main important things, main simplifications, so you can check your answers. But then please try to do it yourself. So what you'd get is 100, 0.5 minus 3.5, 1, 0.5, 0.5 minus 2, 0.500 minus 0.510. Okay, next what you do is, first step is to create a 1 here. So R2 is R2 divided by minus 3.5. Once you do that, you need to eliminate this one, make a 0 here, make a 0 there. So what you can do is you can do these operations. Row 1 is row 1 minus 0.5, row 2, and then row 3 equals row 3 minus row 2. You end up getting 1, 0, 0, 0, 1, 0, 0.5715, and 1429, 1.8571, 4285, 0.1429, minus 1.1429, 429, 0.2857, plus 2.857, and 001. Finally, we use this guy as a pivot. So we need to do row 3 equals row 3 divided by negative 1.8571. After we do that, we do these operations. Row 1 equals row 1 minus 0.5715 row 3, and row 2 equals plus 0.1429 row 3. Okay, so this gives me 1, 0, 0, 0, 1, 0, 0, 0, 1, and then there'll be lots of things here. 0.0767, 0.2304, 0.6154, 0.2308, minus 0.3076, minus 0.1538, 0.3077 minus 0.076 minus 0.5384. Okay, so if everything, well, it worked right, then you should have that thing is A inverse. So if you want to check that, take that A inverse, multiply it with A, pre or post, and you'll get identity. So this is my A. Copy. So I'm going to take that and then write the answer now. We're almost there. So A inverse equals, okay, copy paste it from the previous page. B is given 7 minus 2, 3. I need to compute X, that's A inverse B, which will be A inverse, again copy pasted, and then B. I think I'm just trying to see what answer I got. I didn't quite do this calculation, so you might want to multiply this and check. I did not do this calculation. I mean, I need to just plug it in a calculator. But what I expected that I expect that they to be close to 1, 2, and 3, but not exactly 1, 2, and 3 because I only kept 4 decimal places. So just do this calculation yourself. And check. Answer. The actual answer is 1, 2, 3. Do we have time? 45 minutes. Okay, we have 5 minutes. I could actually modify that code to do this. It shouldn't be too hard. I don't think so. So we got this answer. We want to get the inverse and then do the multiplication. I think we can do this fairly quickly. Let me try to do it with the code which is there. So what I want to do is I want to write a function which will return the inverse of A or any matrix, right? So what we'll do is we'll take this code, since it does everything we want it to do, and then let's call it Gauss Jordan inverse and save so. And then I have this driver. Let me let's to check. So let's call inverse. So what this will produce will be A inverse, and I only want to input it one thing, which is A. And then when I get the solution, I need it to print X equals A. So I don't need this. Okay, so I'll get A inverse B, A slash B, and then I'll get A inverse using my own Jordan inverse, and then multiply, and that will be the answer, right? So let's see if I can get this. I need to, however, main Gauss Jordan. Okay, let's see if I can get it in 3 minutes. Okay, so we have this code, which clearly doesn't have B as the output. There's no B input. When we augment this, we want to augment it with this case row columns equals size A. So we want to make our identity matrix. I with row. So if A is n cross n, 3 cross 3, I get 3, and I augment it A with identity. Now rows, column, this is all fine. Okay. I don't think I need to modify anything over here. When I return, however, I probably need to return A inverse, and then that should be my return value. A inverse is going to be A augmented, everything here, but then I want to go from whatever the columns are till the end. So cols plus 1. No, my bad. It should be col plus, okay, so it should be COL plus 1 till the end. Let's see if it works. Let me also make it print A inverse. Same problem. Let me just try to restart this. Okay. Hey, run this. Change directory. Okay. It seemed to have done our calculations, but I can't see them. So what I'm going to do is go here and then just delete this. Okay, now let's run this. And let's see the output, which is here. Okay, so what it did, row 3, okay, if you check the answer for A inverse with what you have, what we did by hand, it's exactly the same thing, right? And then it used that multiplied with B to give this answer, so it's all right. What I need to do here is probably go here and then comment this out, and then, yeah. Okay, so that actually worked as expected. It gave me an answer. Apparently, it rarely happens that I write a code and it works the first time, so it just worked this time. But one of the good ways of checking, one of the good things about this course is that whatever you do hand calculations, you can always verify them with code. In fact, you can create your own problems because you have access to the code and then check your answers.